Now we will see some more examples for the linear and nonlinear systems. In last class we see the example 3. Now we will see the example 4. Now we will comment on linear and nonlinear directly without solving all these things. We have already seen the procedure for the system finding linearity and nonlinearity. So you can refer this previous video. So now onwards we will see the more examples. Just by seeing the question we need to answer. I will explain that. Now example 4. By seeing this, x of t is the function of sign. So in this it doesn't follow the additivity condition. If we do the procedure as per we explained in previous video, it doesn't follow the additivity condition. Additivity condition doesn't follow. Same homogeneity also doesn't follow. Homogeneity condition also doesn't follow. So this system is nonlinear. System is nonlinear. Nonlinear system. Similarly, mod of x of t. It follows the additivity condition. It follows the additivity condition, but it doesn't follow the homogeneity. Means, if we multiply x of t with minus 5, output we will get with plus 5. Because mod minus 5 becomes plus 5. So if we multiply the input with minus 5 constant, but output is multiplied with constant plus 5. So this homogeneity condition is not satisfying here. So this is nonlinear system. Similarly, this is this mod x of t we can also explain with graphically. For negative t time also we will get the positive. For positive also we will get the positive. So it is not the nonlinear. Similarly, example 6. This example 6 also we can say directly nonlinear because here some constant is adding. So we can see by graphical method. It is passing through this line. So the system is nonlinear. So these all systems are nonlinear. This also nonlinear. This also nonlinear. And this one also nonlinear. These three systems are nonlinear systems. Now we will see some examples in discrete time signals. Discrete time systems. Now we will see in discrete time signals. Discrete time systems. E of n is equal to transfer function of x of n. Example 1. Otherwise we will continue the numbers. 6 completed. Example 7. Y of n is equal to 2 to the power of x of n. We can say that this is First this one, we will explain complete procedure for first one. x1 of x of n replaced with x1 of n, then it becomes y1 of n is equal to 2 to the power of x1 of n. Similarly, x of n is replaced with x2 of n, then the y2 of n becomes 2 to the power of x2 of n. Now x of n, y of n is equal to with combination of y1 of n plus y2 of n, 2 into x1 of n plus 2 to the power of 2 to the power of x1 of n, 2 to the power of x2 of n. Call this as equation 1. Now replace x of n with combination of x1 of n plus x2 of n. Now we will get the transfer function y dash of n is equal to 2 to the power of x1 of n plus x2 of n. By expanding this 2 to the power of x of 1 of n plus, not plus, into 2 to the power of x2 of n. Call this as 2 equation. So equation 1 is not equal to equation 2, means additivity condition is not following. Additivity condition is not following. So this system is non-linear system. The system is non-linear system. Similarly, we will see some more examples. Now onwards we will comment directly on the linearity without doing all the procedure. Example 8. Y of n is equal to signum function of x of n. Signum function of x of n. We can say this is non-linear. Directly say we can say it is non-linear. It doesn't follow the additivity. It doesn't follow the additivity. Similarly, it doesn't follow the homogeneity also. So the overall system is non-linear system. Non-linear system. Example 9. Y of n is equal to complex conjugative of x of n. Complex conjugative of x of n. For example, we will take alpha as 2 to the minus j3. Then we will check y of n is equal to alpha into conjugative of n, means we are multiplying input with the constant alpha. So substitute alpha 2 to minus j3 into complex conjugative of x of n. Alpha is this one. Take alpha is this one. Now replace x of n with alpha into x of n. Then y of n becomes alpha into x of n whole conjugate. Then 2 minus j3 into x of n complex conjugate. Now 2 minus J3 becomes conjugate 2 plus J3 into X of n complex conjugate. So we can say that this is not following the homogeneity condition, because it is not following the homogeneity conditions, because this is why it has happened. 2 plus J3 complex conjugate of Y of n, because here we are multiplying input with alpha as 2 minus J3, but in output we are multiplying with 2 plus J3. So homogeneity condition is not following. 2 minus J3 multiplied input with 2 minus J3, but output is multiplied with 2 plus J3. So we are not following the homogeneity condition. Homogeneity condition is not following. So the system is nonlinear. System is nonlinear. Nonlinear system. We can say direct. Okay, thank you. Thank you.